All right, so today we're going to be going over the Module 2 test review. We've got 10 questions to cover. So the first one says evaluate f of -2 for the function, and it gives you the function. So all I'm doing is I'm plugging -2 in for x. So anywhere I see an x, I'm going to plug in -2. So f of -2 equals -2 squared minus 2 times -2 plus 6. I like to put my whatever I'm plugging in parentheses. That way I know that piece goes together. That's what's being inserted into the equation. And then from here, you want to follow your PEMDAS. All right, so we start with parentheses. Do I have anything in parentheses that I need to solve? Well, I don't have anything I need to solve for. I have -2 in parentheses, but there's no solving happening there, so that's fine. Do I have any exponents? I do. I have an exponent. This is my exponent. So I'm going to do -2 to the second power. That's doing -2 times -2. -2 times -2 is 4. I'm going to bring everything else down with it. All right, so we did our exponent. Now we're going to go on to multiplication and division. Remember, that happens left to right. So if I see it, I'd be going from left to right. So I have multiplication right here, because I remember when two things are right next to each other, we're multiplying. -2 times -2 is +4. Bring everything else down with me. So +4, bring down my 4, bring down my 6. And then we have addition subtraction. Again, we go from left to right. 4 plus 4 is 8. 8 plus 6 is going to give me 14. And that is our answer. That's it for the first one. You're just plugging in for x. All right. Let's go to the second one. For the second one, looks like we're doing the same thing with just a slight twist. So I have two pieces I'm looking at in this case. I'm looking at f of 3 plus f of 2. So what you're going to do is you're going to solve when x is 3, and then you're going to solve when x is -2, and then once you get those two answers, you're going to add them together. So you can do two separate equations and then add them together, or you can do one big equation. I'm going to do one big equation because that's a little bit more comfortable for me. I'm going to put each equation in a set of parentheses. That way I know that's what I'm inserting in. So the first one, I'm going to do f of 3 on one side, and then I'm going to do f of -2 on the other side. So I'm going to rewrite my equation. I have -4. I'm going to put a parentheses because I know I'm plugging something in for x. -6. Same thing on the other side. -6. All right, and for the first piece, I'm plugging in a 3, so I'm going to put my 3 down in there. For the second piece, I'm plugging in -2. So I'm going to start by solving this first set of parentheses. Remember, I follow PEMDAS, so P for parentheses. I have this entire piece in a parentheses, so I know I'm doing this piece first. Don't have any exponents. I have some multiplication, so I'm going to go to multiplication. -4 times 3 is -12. Bring down my -6. -12 minus 6 is -18. So this is the answer to f of 3. So when x is 3, my y value is going to be -18. But I'm not done yet. I'm going to add that, and I'm going to do the same thing on the other side. I'm going to do -4 times -2. That's going to get me +8 minus 6. 8 minus 6 is 2. So now I'm doing -16 plus 2. -16 plus 2 is going to give me, or -18 plus 2 is going to give me -16. And that's your answer. Now make sure you remember that this is your x values, and your output is going to be your y value, whatever you get from the equation. All right, good on this end. We're going to go over to number 3. So for number 3, it says for each equation, does it represent a linear or nonlinear function? So I'm identifying linear and nonlinear. We need to remember that linear functions are going to be either written as y equals mx plus b or ax plus by equals c. Now you also need to remember that the highest degree of a linear equation, or the highest exponent, is going to be 1. Any exponent greater than that is not going to be linear. So that's what I'm looking for. I'm either looking for an equation in one of these formats, or if I were to move it around and simplify, it would come out to one of these formats, and that the highest exponent, or the highest degree, is 1. So I'm going to look at the first one. Now, I know every variable, if it doesn't have an exponent, its highest degree is 1. I have an x, I have an y, I know this is linear. Now, although it is not exactly in these formats, if I were to rearrange this equation, if I did x equals negative 7y plus 2, and I move this negative 7y to the other side, I'd move something to the other side of the equal sign by doing the opposite operation, I would get x plus 7y equals 2. And that would give me a format that looks like this one. So I know this is linear one way or another. All right, let's look at the second one. It has a power 2 in x. So anything with a power 2 in x is going to be an automatic exponential. All right, let's look at the next one. So we've got x times x plus 1 equals y. So before I can identify, now some of us might get confused because this has a 1 and this has 1, and we might think, oh, it's linear. But before I can do that, I have to look at what's happening here. What's happening between this x and everything in the parentheses. So if I were to have something right next to the parentheses, I know that that's multiplication. So this x is actually multiplying with the x and the plus 1. So before I can identify if this is linear, I need to simplify this equation. So I need to do x times x, which gets me x squared. X times 1 gets me positive x, or 1x equals y. Now, the highest degree in this problem is no longer 1. It is 2. So this would be a quadratic. So it is non-linear. And so is B, sorry. Non-linear. All right, and now we look at D. So D is written as 6x plus 5y equals 12. And if we notice, that is in the same format as our standard form. So this is linear. Linear. All right. And let's go to the next one. All right, so it wants us to evaluate again. We're plugging in. Our input is going to be 4. So when x is 4, we're looking at what's going to be our y value. So I'm going to rewrite my equation. F of 4 equals 4. I'm going to put a parentheses because I'm going to hold the place for that number. Over 2 minus 3. I'm going to put my parentheses because there's another x here, plus 5. And in my parentheses, I'm going to plug in a 4 because it's telling me to plug in that 4 for x. And now we follow PEMDAS. So we're going to start with parentheses. Now I don't have anything to solve in parentheses, so nothing to do there. Don't have any exponents. And now we're going to be looking at multiplication division. Now remember, multiplication division is left to right. So I'm going to start on the left side, move over, work my way down. So first I need to do the top. This comes first. What's 4 times 4? We've got 16 over 2. Bring everything else down. Again, we're going left to right. So I need to get rid of this fraction first. 16 divided by 2 is 8. Bring everything else down. From there, we've got multiplication going on right here. I've got negative 3 times 4 is negative 12. Bring everything else down. Now we've got addition, subtraction. We're going from left to right. 8 minus 12 is -4 plus 5 is +1. So that means f of 4 equals 1. That means when x is 4, my y value is going to be 1. As a point, this would be 4, 1. And that's our answer. On number 5. So, it says for some function f, the number of dollars Sarah has left is dependent on the number of pencils x she buys. Which of the following describes what f of 20 represents? So I want to know in words, what does this f of 20 mean? So I'm going to write it down over here, f of 20. So they told me what x was. They told me x represented the pencils. So I know this is talking about Sarah's pencils. Now, Sarah's pencils, however many she buys, that's going to tell us how much money she has left. So if x is pencils, our entire unit, f of 20, is going to tell me how much money she has left. So that's what I'm looking for. I'm looking for which answer choice is going to tell me that when Sarah buys 20 pencils, she has however much money left. Because this f of 20 is our y value. Remember, f of x is the same thing as y. So whatever this entire piece tells me, that's my y value. This is my y value. So if Sarah buys 20 pencils, I'm going to figure out how much money she has left. So A says Sarah spent $20 on pencils. Well, no, we didn't spend $20. It says X represents the pencils, and instead of X, we put a 20. So that means she bought 20 pencils. So that's not going to work. And it says Sarah has $20 left after buying F number of pencils. Well, we know F is not the variable that represents X. F represents the number of dollars Sarah has left. So I know that's not the answer. And finally, it says the amount of money she has left after buying 20 pencils. Well, yeah, Sarah bought 20 pencils. This entire piece, f of 20, is going to tell me what she has left. All right, let's move on to number 6. All right, so it says below are the tables of two functions, t of x and p of x. So we've got t of x and we've got p of x. It says which graph has a larger x-intercept? Well, first I need to remember what x-intercepts look like. I know x-intercepts, if I have a graph, x-intercepts are touching this horizontal line, this horizontal axis. So I know that if it's touching this x line, I know I'm moving left and right. But because I'm staying on this line, I'm not going up. So I know my x-intercept is going to look something like this. Y has to be 0. Whatever the case may be for x, doesn't matter. Y has to be 0. So I'm going to go in and I'm going to look at when y is 0. So on t of x, I've got one x-intercept. And I've got another one in p of x. So I'm going to look at these two. And it wants to know which x-intercept is larger. So if I had a number line, and I know my y values are the same, so I'm not looking at my y values, I'm looking at my x values. So if I had a number line, and I had 0 in the middle, 1, 2, 3, 4, 1, 2, 3, 4, -1, -2, -3. And I'm looking at 1, and -1. Which is bigger? Well, 1 is higher up on my number line. So I'm going to go with p of x. P of x is bigger than t of x. It's x-intercept at least. Alright, then it says, which graph has a larger y-intercept? Well, I'm going to look at the same thing. I know y-intercepts are where does my graph touch my vertical line. So I'm looking at this line. So if I know this vertical line, my graph has to touch this vertical line. I know when I start at my origin, I am not moving left or right. I'm staying on this line. So I know this is going to be 0. And whatever I move up and down, that's what y is going to tell me. So I know my x value in this case has to be 0. So I'm going to go in, I'm going to look at t of x, which one has an x value of 0. All right, we've got 0, 3. Now I'm going to go to p of x, and I'm going to look at which one has a 0. We've got a 0 right over here. All right, so I'm looking at, I know their zeros are the same, so I'm not looking at their zeros, I'm looking at their y values. Which one is larger? So if I were to graph 3 on the number line and 2, 3 is higher up, so I know my answer is going to be t of x. All right, and let's move on. All right, 7. For number 7, it says, based on the following graph, which statement is true about the graph? So we've got 4 options, and it looks like we're talking about whether it's a function or not a function, whether it's linear or non-linear. So I'm going to start with function. I want to identify, is this a function? So in order to tell if something's a function, I'm going to do the vertical line test. That means I'm going to draw straight vertical lines through my graph, and if my graph at any point touches the same vertical line more than once, I know it is not a function. So I'm going to start drawing just straight lines through the graph. Now they should be straight, because that's the only way we can tell, or as straight as you can make them. And that's the only way we're going to be able to tell. So if my graph touches the same line more than once, I know it is not a function. And I'm looking here, and it looks like it's only touching my vertical lines once. Not seeing any points hitting it twice. So I'm going to go with it is a function. So I know it's a function. So I can look at my answer choices, and I can eliminate anything that says not. I know it's not A, and I know it's not C. So now I'm going to look at whether it's linear or non-linear. Now remember, linear means it is a line. It's in the name. So I know I can have a diagonal line, or a horizontal line. These are all my graph options. Because remember, vertical lines are not functions. And if I notice, this doesn't really look like a line. It looks more like a curved line. This graph is actually called an exponential function. And an exponential is not a linear, it's not a line, so I know it is non-linear. I know it's B. Alright, so let's keep going. We've got number 8. Alright, so Steven is a professional pool diver. The graph shows how high he dives from over the number of seconds. Which statement is false? So I'm looking at what's true, what's false. Alright, so let's go one by one. We're going to read our graph. We're going to pinpoint the ones that we see are true and the ones we see are false. So in this case, we're talking about the height. I'm assuming Steven's height from where he dove and how long it took him in his dive. So this is the trajectory Steven took. So to help you visualize a little bit, I'm going to draw a little line over here. I'm going to draw Steven. Steven hopped up on the diving board. He decided to jump, and then he went back down. And so finally, at this point, he hit the pool surface. So I know this straight line, the x-axis represents when Steven hit the pool surface, right? And if I see here, we're talking about seconds. So it took Steven 3.5 seconds to go from the top of the diving board all the way down to the pool surface. Okay, so knowing that, I'm going to go back and I'm going to look at my answer choices. So A says Steven hits the pool surface after 3.5 seconds. So I know Steven went up, he went down, he went down, he went down, he finally hit. He hit at 3.5 seconds. So I know that's true. Because Steven did hit the pool surface at 3.5 seconds. I see it here. Alright, Steven jumped from 25 meters. So where did Steven start? Steven's path started here. It looks like it's in between 24 and 26. So it did start at 25 meters. That means Steven jumped from 20 meters up. Then it says Steven hit a maximum height after 3 seconds. Well, I'm going to look at where does Steven have the highest point. So Steven went up, up, up. It looks like right over here. It looks like Steven did not pass this. Was his trajectory. The highest point he hit was right here. And that is on 30. So Steven did hit. Oh, it says maximum height after 3 seconds. So let's hold on. Let's look at how long it took Steven to get there. So I know his maximum height in meters was 30 meters. But I'm going to look at his time. I'm going to go straight down and see where my time hit. Oh, so it looks like Steven hit his highest point after 1 second. That is not 3 seconds. So I know this one is false. And I know that's my answer. Let's look at the last one just in case. So it says Steven reaches a maximum height of 30 meters. And we did decide that Steven did hit the top of the highest point in his dive at 30 meters. So I know that's a true statement. Alright. We've got 2 more. So Steven decides to buy some games from GameStop. He only has $60 to spend on games for his Nintendo Switch. How many games can Steven buy with $60? So if we look at our graph, we can see that our x, if we look at our graph, we can see that our x-axis represents the number of games Steve rented. So it looks like he's renting, not buying. But that's okay. We can see how many games he's renting. And if we look at our y, we can see how much his games are costing. So this graph tells us when the two things meet, how much his prices are in relation to how many games he rents. So if Steven decides to rent 5 games, well, that's going to cost him, it's going to be him right here between 20 and 30, so 20 and 40, so I can assume that's $30. If Steven rents 10 games, we're looking at, he's hitting at $40. So 10 games is going to cost him $40. And we can keep going from there. So I want to know how much Steven can buy with $60. So I'm going to go to $60. I know this is what Steven can spend. I'm going to go all the way down and see where $60 hits our graph. Well, it looks like it hits right over here. It looks like it hits at 20. So that means for $60, Steven can rent 20 games. So I know he can rent 20 games with his $60. Alright, and our number 10. It says describe the end behavior of a negative linear function. So first I need to identify what a negative linear function is. So I know negative, when something's negative, it's going down. So I know I'm looking at something that's going down. And I know linear is a straight line. So it looks like I'm looking at a straight line that's going down. I'm going to draw my graph so I can visually see it. This is 1, 2, 3, 4, negative 1, negative 2, negative 3, 1, 2, 3, 4, 1, 2, 3, 4. If this was my graph, this is my negative linear line. I don't think it doesn't really say anything specific about the line, so we can just draw a line going down. And I know it's going down because when I read my graph from left to right, remember we read things from left to right, if I put my little person on here, he's walking down the mountain. So I know he's coming down. We're going from left to right. So that's how I know this is negative. It's going down. Alright, so if I go, I'm going to be looking at the end behavior. So remember, all end behavior starts with, as the value of x increases, the value of y blank. As the value of x decreases, the value of y blank. So I'm going to look at when the value of x increases. So when my x's are going up, remember these are your x, your horizontal line is your x's. As these values go up, we've got 1, 2, 3, 4. As these keep going up, 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 I'm looking at what's the end of my graph doing, and it looks like it's going down. It is decreasing. So as my x's go up, as these numbers go up, 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 my end behavior is going down. So the y values are decreasing. Now Now I look at the other side. So it says as my x's decrease, as these go down, -1, -2, -3, I'm looking at what's my end doing. What's the end of my tail doing? So as these x's decrease, looks like my tail's going up. So my y values are going to be increasing. Alright, and it looks like that's it for today. That's the end of our Module 2 review.